All right, today we are cracking the code on three of the most important and, let's be honest, most confusing terms in data: covariance, correlation, and causation. And look, understanding the difference isn't just for stats nerds. It's like a superpower for thinking critically about pretty much everything you see. So let's start with a classic puzzle. It is a statistical fact that when sales of ice cream go up, the number of shark attacks also goes up. So, what's going on? Does eating ice cream suddenly make you delicious to sharks? Or maybe after an attack, sharks just get a craving for a waffle cone? It sounds completely absurd, and you're right, it is. But this is exactly the kind of trap we're here to figure out. To solve puzzles like this, we need the right tools in our toolkit. So our first goal is simple. We just need to find a way to measure if two things, two variables, are even moving in the same direction to begin with. We gotta have a starting point. So let's dive into that first question. How do we even measure direction? Before we can get fancy and talk about how strong a connection is, we first have to figure out if two things are moving with each other, against each other, or if there's no relationship at all. Okay, meet our first tool. It's called covariance, and its job is incredibly simple, very focused. It looks at two sets of data, and it tells us one thing, and one thing only: which direction is the relationship going? That's it. Think of it like the compass for our data journey. Covariance gives us a really straightforward answer. If the number it spits out is positive, it means the two variables tend to move together. You know, like when the hours you study go up, your grades also tend to go up. If the number's negative, they move in opposite directions, kind of like a seesaw. One goes up, the other goes down. Okay, great. So covariance gave us the direction, but that just opens up a much bigger, more important question. We know they're moving together, but how together are they? Is it just a weak little connection, or are they practically tied at the hip? Covariance, well, it can't tell us that. The number it gives us isn't on any kind of standard scale, so it's kind of useless for measuring strength. We need an upgrade. And this is where our second tool comes in. It's a major upgrade that lets us measure the actual strength of the connection. This is correlation. It's going to not only tell us the direction, but crucially, how strong that relationship really is. And yep, that tool is correlation. You've probably heard this word thrown around all the time. What makes it so incredibly useful is that it does two jobs at once. It confirms the direction, just like covariance did, but it also gives us a hard number that tells us the strength of that relationship. So to put it as simply as possible, covariance just points the way. Correlation, on the other hand, tells us how clear and well paved that road is. It gives us a much, much fuller picture. And here's the magic of correlation. This is why it's so powerful. Everything is boiled down to a super simple, intuitive scale that always goes from -1 to +1. It doesn't matter if you're measuring dollars or pounds or miles, the scale is always the same. And that makes it incredibly easy to compare and understand. So, for example, let's say you get a correlation of positive 0.98. Whoa, that's almost a perfect +1. This means those two variables are moving together in almost perfect lockstep. When one goes up, the other goes up, and you can be pretty darn sure of it. It's a super strong link. Okay, so what about a negative number, like -0.70? Well, the negative sign tells us it's that seesaw relationship. One goes up, the other goes down. And because 0.70 is a good ways away from 0, this tells us it's a pretty strong negative relationship. They are reliably moving in opposite directions. And what if you get a number like, I don't know, positive 0.20? Well, the plus sign tells you there's a slight tendency for them to move in the same direction. But because that number is so close to 0, the relationship is really, really weak. It's barely even there. So now we have this amazing tool, correlation. It tells us direction, it tells us strength, we're feeling pretty good. And this right here is where most people make the single biggest mistake in all of data analysis. This is where we face the final boss, the causation trap. I mean, it's the next logical step, isn't it? If we find this super strong correlation, like that plus 0.98 we saw, it must mean that one thing is causing the other thing to change. It just feels so intuitive, so obvious. But it's wrong. Dangerously wrong. You need to burn this phrase into your brain. Seriously, say it with me. Correlation does not imply causation. Just because two things are strongly connected, it does not ever automatically mean that one is making the other one happen. This is probably the most important thing you'll learn today. You see, for something to be actual causation, you have to prove a direct mechanism, a real cause and effect link. You have to be able to show that changing variable A is directly responsible for the change you see in variable B. Correlation is just a clue. Causation is the final verdict, and that requires a whole lot more evidence. Okay, enough with the theory. Let's make this really concrete. We're going to use a simple, real-world example from the stock market to see how all three of these concepts, covariance, correlation, and causation, work together. So imagine we're financial analysts, and we're looking at the stock prices for two tech companies. Just by glancing at the numbers, you can kind of see that as company A's price goes up, company B's seems to be tagging right along with it. But let's run the numbers and see what they really tell us. First up, we calculate the covariance. We get a value of 54. Now remember, the number 54 itself doesn't really tell us much about strength. The only thing we care about right now is the sign. It's a positive number, so that confirms what we saw with our eyes. The stocks are moving in the same direction. Check. Okay, now for the big one. We calculate the correlation. And wow, we get positive 0.98. This not only confirms the direction, but it tells us the relationship is incredibly strong. I mean, it's almost a perfect positive correlation. These two stocks are basically dancing in perfect sync. And this is where it all comes together. We have this amazingly strong correlation. So can we stand up and say that company A's good fortune is causing company B's stock to go up? No, absolutely not. What's far more likely is that there's some third hidden factor, like a major boom across the entire tech industry or great economic news, that's lifting both companies up at the same time. They're correlated, for sure, but one is not causing the other. And that right there finally solves our shark and ice cream mystery. The strong correlation wasn't because of a weird causal link. It was driven by a hidden third factor: hot weather. Hot weather makes more people buy ice cream, and it makes more people go swimming in the ocean, which unfortunately leads to more shark encounters. So next time you see a headline or a chart or a post online claiming one thing causes another, stop and ask yourself, what else could be pulling the strings here? Because finding that hidden answer, well, that's the real secret to truly understanding the world through data.